We are going to be spending 3 days going over systems that have quadratic equations. So far, all we've done is taken a look at systems that had 2 or 3 linear equations. For the first one, it says, go to Desmos.com to graph the following graphs on the same coordinate plane. So you could graph it on this base if you want to be able to look back at it later, or I'm just going to go ahead and go to Desmos.com and plug in these two equations. In Desmos, you will see that the first equation was a linear function and the second equation was a circle. For the first equation, we could have solved for y to get it in slope-intercept form. You would have seen that the intercept was 0 and there was a slope of 1/2. For the second equation, we have the x squared plus y squared equals 125. Whenever you see this format, x squared plus y squared equals some number, it's going to look like a circle. The circle will have a radius of whatever this is squared. So take the square root of 125, and that will give you 11.18. Checking the circle, you can see that the radius is 11.18. So just so you know how we got to that graph, let's answer the question. So you can go ahead and look back at your notes, but I'm gonna just talk about it while looking here on Desmos. It says, what are the intersection points? It's nice because on Desmos you can just click the points of intersection. If you could please write down that the points of intersection are -10, -5, and 10, 5. The next question says, how can you verify these algebraically? So one way that we can verify this is we can plug them back into the equations and check to be sure they're working. For example, in this first coordinate, it's x and y. So I'd plug in a -10 for the x, a -5 for the y. You would see it's -10 minus 2 times -5, so plus 10. -10 plus 10 is 0. So to verify, we could check them by plugging in to both equations. And then for the next question where it says, how can you have solved this without graphing? What we're going to be doing in order to solve without having to graph every single time is we are going to be using substitution, which is an idea that you already know. However, I will say that a lot of algebra mistakes have been made in the past, so we're going to use Desmos to check our answers. Number 2, there's 2 different problems we're going to be attempting. First thing we're going to do is this part A right here. We have 2 different equations and we're going to solve them algebraically. Once we're done, we'll check our answers on Desmos. If you're going to be using substitution, you want to rewrite the linear equation and plug it into the circle equation. It doesn't matter if you rewrite solving for x or y. In this case, I think it would be easier to solve for y because I would just add x to each side, leaving me with y equals x plus 7. And now that it's rewritten, we can take that equation and plug it into the first one, remember the circle equation. And what that would look like is we would have x squared plus y, which was x plus 7 squared, equals 25. Now here's where I see a lot of the mistakes. Many people would like to distribute that 2 to each term. However, we cannot do that. You can only distribute the power if you have multiplication or division. When you're adding or subtracting, you need to FOIL it out. So what this really is going to look like is I'm going to have to rewrite x plus 7 squared as x plus 7 times x plus 7. And again, we are going to FOIL. We have x squared plus x times x is x squared. X times 7 is 7x. 7 times x is 7x. 7 times 7 is 49. Now we are going to combine like terms. Because it's a quadratic equation, you want to get it set equal to 0. So I'm going to move the 25 over and start combining like terms. 1x squared plus 1x squared is 2x squared. 7x plus 7x is 14x. And 49 minus 25 would be a positive 24 and equals 0. What you would like to do at this point is try and factor. Remember, before you factor, you need to check for a GCF first. Looking at these terms, I do see that there is a GCF of 2, so I'm going to go ahead and pull it out. Remember, what goes in the parentheses would be each term divided by the GCF. So that's how I got this right here, the x squared plus 7x plus 12. When we're factoring a case 1 trinomial, which is what this is because a is 1, we could list out the factors of 12, so 1 and 12, 2 and 6, 3 and 4. Using the same signs because it's positive, how would I get to a positive 7? Well, that would have to be positive 3 and positive 4. So we have 2 times x plus 3, x plus 4 equals 0. The solution is what we would get by setting each equal to 0. So the GCF being set equal to 0 does not give me a solution. X plus 3 equals 0 gives me a solution of negative 3. And x plus 4 set equal to 0 gives me a solution of negative 4. So we have 2 x values, which means we're going to have 2 points of intersection. In order to write our final coordinates, we would have to find the y values, and we do that by plugging them into one of the original equations. I personally think it would be easier to plug it into the second equation, so that's what I'm going to do. I'm going to do this in a different color, and I'll do it right at the bottom here. So for when x is negative 3, I'm just going to plug negative 3 in for x to the second equation. So y minus x would be y minus negative 3 equals 7. That becomes y plus 3 equals 7. Subtract 3, we have y equals 4. So 4 goes with the negative 3x value. And now we are going to look at when x is negative 4. We just plug the negative 4 in for x. So y minus negative 4 equals 7. That's y plus 4 equals 7. Subtract y equals, oops, I'm sorry, I didn't realize you couldn't see that. Y equals 3. So 3 would go with the negative 4x value. I would like for you to try this one using the first as a reference. When you are done, hit play so you can check your work, and I'll talk about a few things with this problem. The first thing you should have done is rewritten the linear equation so that it's either x equals something or y equals something. It didn't really matter, but if you did x equals something, your work will look a little bit different than mine. Now, if you solve for y and plugged it in for y here, we would have x squared plus 17 minus x being squared equals 169. It's the same thing as before. Because this is squared, we need to multiply it by itself and FOIL it out. You cannot distribute that 2. I know it looks a bit weird with the x being here and the constant being here. If it bugs you that much, you could have written this as minus x plus 17, so you didn't have to deal with it. But here's what you should have ended up with it being FOILed. Combine like terms. Once you've done that, you should have pulled out a GCF of 2. Listed out the factors of 60 using same signs, getting to a 17 would have been -5, -12. So that gave us solutions of 5 and 12. Plug that back into one of the original equations or our rewritten equation 1, and you should get the y values. Make sure you write your final answer as coordinates. If we were to check our work using Desmos, here's part A of number 2. You can see we got -3, 4 and -4, 3. And here's part B of number 2. You can see the points of intersection are 5, 12, and 12, 5. In solving number 3, it's the same process where we want to rewrite the linear equation so that it is written as, I was going to do y equals something, but now I realize it'd be easier if I did x equals something. So I'm going to rewrite this as x equals, and all I have to do is subtract 2y from each side. So -2y plus 16. Using this, I'm going to plug it into my first equation. So I'm replacing x with -2y plus 16 squared plus y squared minus 36 equals 0. Make sure that we rewrite the expression being squared as something times itself because we cannot distribute that power of 2 due to the addition sign. FOIL this out. -2y times -2y is a positive 4y squared. Then we have a -2y times a positive 16, which is a -32y. Once again, we have a -32y. 16 times 16 is 256. And we still have plus y squared minus 36. Because it's a quadratic, we want to set it equal to 0, and it already is. So let's go ahead and combine like terms. So all of the y squares together, I see 4y squared and 1y squared, which is 5y squared. And all of the y's together, so these two put together is minus 64y. And then we also have to combine our constants. So if I add those together, I get a positive 220. There is no GCF here, and if you were to try and factor it, it ends up not being factorable. When you have something that's not factorable, you can try the quadratic equation. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I recommend you write this down because it will be on your homework. Now when I plug it in, I'll just show you real quick. When I plug in my a, my b, and my c to that equation, I end up with 64 plus or minus the square root of a -304. So that would give me an imaginary number, so that's no real solution. That's what I'm going to put here, no real solution. Let's check what this looks like on Desmos. As you can see here, there's no point of intersection, which is why we got no solution when solving algebraically. Number 4 asks, how can a linear function in a circle have only one intersection point? Draw a rough sketch. So far you've seen 2 points of intersection, because if I have a circle and a line, it intersects twice, like this. You've also seen no solution, which is where we have a circle and a line that does not intersect it. So if I only want one solution, it would have to be a circle where the line just barely touches it, but doesn't go all the way through. So just touches the circle. Number 5 asks, can a linear function in a circle have infinite solutions? The answer is no. And the reason why is because for it to be infinitely many, they have to overlap perfectly. Like when we had 2 linear functions and they overlapped each other perfectly. That's infinitely many. There's no way using a circle and a line that you can overlap every single point. That would have to be a circle and a circle, or a line and a line.